Hello, hello. This is your recap for the second torque practice. The very first question is very simple. We are looking for the value of the torque. Here we have the distance. If this is our axis of rotation, the distance is given to be 15 centimeters, which is 0.15 meters at 90 degrees, even though it doesn't really look so, but that's the force at 90 degrees. Mine is not either, but they believe that this is 90 and this force is 100 newtons. So therefore torque is the perpendicular force times the distance, which is 100 newtons, because it's at 90 degrees to the object, times 0.15. That gets us torque equal 15 newtons times meters, and it's counterclockwise, so it's positive. In question 2, they're asking what would be the force if the wrench, which is the distance, was a whole 1 meter long. So what would be this force to produce the same amount of torque? And it equals force times 1 meter. So this force right here would have to be only 15 newtons, which is much less. Number 3, we're going over figuring out whether it's clockwise, counterclockwise, or zero. Remember, to figure it out, you hold your fingers right here at point P, hold your pencil with your fingers in the middle, and then apply the force. This would be counterclockwise, pretty easy. Same here. If you place your fingers right there in the middle of your pencil and then apply force downward, you're going to get a counterclockwise torque. By the same token here, get your fingers in the middle and then apply the force this way. That's going to be clockwise, which is negative torque. And then the same thing here. Hold your fingers here, apply the force this way. That's clockwise, which is negative. So the torque is counterclockwise positive and clockwise negative. Question 4, here we have, that's our object. The whole object is 2 meters long, and we have 2 axes of rotation. The first one is A. So when you look at A, because this is your axis of rotation and the force of 5 newtons goes straight through it, then 5 newtons will have 0 lever arm. Therefore, its torque is going to be 0 newtons times meters. Then we have another force of 20 newtons. That is going to produce a counterclockwise torque, and the distance to point A is, the whole thing is 2 meters. So this distance right here is 1 meter long. So 1 meter times 20, it's going to be positive 20 newtons times meters. And now for 10 is providing a counterclockwise torque again, with the lever arm being 1 meter. So it's just 10. So there we go, positive 10 newtons times meters together, 20 plus 10, that becomes 30. So 30 newtons times meters, it's positive, and or you can say counterclockwise. Then for point B, again, we are looking at the force that goes through it. If this is our axis of rotation now, then it's the force of 10 newtons that produces 0 torque because it's going through that axis of rotation. And then 5 newtons now has a torque of negative 5 newtons times meters. It's negative because it's clockwise, because if you hold your fingers right here, then you're going to create a clockwise rotation, and then 20 newtons is a whole 2 meters away from the axis of rotation now. So it's going to be 20 times 2, that's 40, and that's counterclockwise again. So 40 counterclockwise, it's positive, so 40 newtons times meters, and then we subtract 5 from 40, and we end up with 35 newtons times meters, or you can say again counterclockwise, that's why it's positive. The picture's on one side and the values are on the other, so I'm just going to go over here. This axis of rotation would give me torque of 5 to be 0. And the interesting thing is this force, because this is the line of the force, and it goes straight through both axes of rotation. So this one will have 0 torque, regardless of where our axis of rotation is. It's going to be 0 torque through A and 0 torque through B. This force right here is in the middle, midway, 0.5 meters away from B and 0.5 meters away from A. Now, if our axis of rotation is here, then it creates the clockwise. So it's going to be negative 10 newtons times meters. And if B is our axis of rotation, then it's creating a counterclockwise torque. And again, it's going to be 10. So overall, 0, 0. Then we have, like I said, 0 for A, but then clockwise. And then for point B, it's a whole meter again. So that's going to be negative 5 newtons times meters. Then force 2, that's 0.5. So it's going to be 10 and 10 newtons times meters. And one of them is positive, one of them is negative. Positive is the counterclockwise, which will be relative to B. So this is positive and this is negative. Net torque here is negative 10 newtons times meters, and negative 5 plus 10, that's going to be positive 5 newtons times meters. Or you can add this is clockwise, 10 clockwise, and 5 counterclockwise. That's how we solve these. Now 6, in 6 we have these forces opposite to each other. This is double the force, but the distance is half of this. If I call this distance, then this is only half of the distance. Force that is double times distance that is halved is the same as just force times distance, which is this way. So this is zero torque. Both are balanced. These two are not at the same lever arm. So this one is closer. If I had force times distance plus force times distance, that would be the same as 2 forces times distance, like over here. But I have distance over 2. So this is greater. So it's going to outpower it, and it's going to be clockwise. And then here, both of these forces are counterclockwise. So we have 2F times distance counterclockwise, and then only half minus force times distance over 2. So definitely it's going to be counterclockwise, which is going to be positive. So positive and negative right here. I'm going to stop here, and then I will see you for this long question in the next video.